What's up, YouTube? Woo! Mr. Keen coming live. Not from the studio, though. From the classroom. That's right. I'm back, baby. Better than ever. So pause the video now, and please answer the questions. Next, don't forget to take the Ionic Bond quiz from yesterday. And today, you will be able to predict how non-metal elements can get their full orbital without using a metal to help. Okay, so we are going to do some notes today. So can you go to classwork, and then go to Thursday, Covalent Bond notes, and pull up the Google Doc. Put your name on it. Okay, so you're going to learn how can elements bond without a metal. Okay, so we're just going to jump right into it today. First, I do want to review, though, the first type of bond that we learned about is called an ionic bond. And that's a bond that creates ions. That's what the ion means. It means that it creates atoms with a charge. How it works, you need a nonmetal and a metal. So the metal doesn't really want its electrons, so it will give away its electrons to the non-metal. So the metal gives its electrons to the non-metal because the non-metal wants it more. And then after, the one that lost its electrons is positive, and the one that gained its electrons is negative. And the positive and negative attract each other because opposites attract. And now they also are more stable because they have a full orbital. But that's going to be different than the type of bond we're going to be learning about today, covalent bond. But first, I want to tell you about a problem. What if, so atoms by themselves aren't stable. A lot of times, sometimes like people, they're not stable if they're alone. So oxygen, right now, it has 6 valence electrons, but it wants 8. It needs a partner that can help it get to 8 valence electrons. So it needs to do something. And it can't find a metal, so I can learn what's the solution today. But first, I want to tell you a little story. Something similar happened to me at Applebee's. So you're on a date, and things aren't super serious, so you take your date to Applebee's. When you look at the menu, though, you notice that all of the dishes are above $10. And you want to pay for them too, but you only have a $20 bill. So what should you do? Note, you can't let your date know that you only have a 20. So you see that everything's above $10, you only have a 20, and you want it to look like you're not cheap. Even if you are, you don't want to look that way. So what can you do? You have a 20, everything's above $10. Please pause the video now. Ask your friends or family for help if you're not sure. Okay, think about it. One of my students had a great suggestion. Just pretend like you're not hungry and say, how about we share a meal? That would be a way to be able to, both of you have some food and you look good. You don't look cheap. That's one option. Another one, if you know your Applebee's, you may know that Applebee's has a 2 for $20 discount. But when it comes time to pay, you don't have any way to leave a tip. So you don't want to look any cheaper. What should you do? You just use your 20. Don't want to look cheap, so you want to leave a tip. What could you do? I'll give you a hint. You could ask your date for help this time because your date hasn't helped at all. At all. So one thing you can do is ask your date to share. You can say, hey, I paid for the dinner. Could you leave a few bucks for the tip? Usually they'll be okay with that. And it's the same with atoms. If they can't find a metal, like if oxygen can't find a magnesium or another metal, then it can ask a different thing to share with them. And that is what oxygen does. In fact, the gas that we inhale is 2 oxygen atoms bonded together. They're sharing their electrons. And you're going to learn more about that today. So, first I want to give you a math problem. Fluorine. Fluorine here has 7 valence electrons, and it sees another fluorine that also has 7 valence electrons. They both want to get to 8, and they both have 7, but how many do they both need to share to get to 8? How many electrons do they both need to give up and share to get to 8 valence electrons? When I say give up, I mean they both are going to share it between each other. So what they're going to do, they're both going to give up 1 electron. They both want 7. They both have 7, but they want 8. 8 minus 7 is 1. So they do both share 1 electron. Here's how it works. So fluorine and the other fluorine gave up 1. So now these electrons are shared. Both of the fluorines can use these 2 electrons, and the fluorines still have their 6 on the outside. So now they have these 6 here, and then they have 2 in between. So now they have the 8 that they want. That's why sharing is caring. And that's why caring is sharing, because these valence electrons can be used by both of them. So now they both are able to figure out a way that they could get the 8 valence electrons that they need. Okay? And that leads us to our first type of important bond, the covalent bond. We talked about ionic bonds before, but these ones are a little bit more important and a little bit more tricky. Covalent bonds are between non-metals, and covalent, think of it as sharing electrons. So covalent bond is when you share electrons to get a full orbital. Okay? So my fluorine example, this fluorine gave a black valence electron, this fluorine gave a red valence electron. And now they both can use these two, so they both can have their complete covalent bond. A lot of times you'll see them in drawings like this too. And in fact, you'll see them more as like little dashes when we do it later on. This is a single, a double, and a triple covalent bond. We're going to practice that more today. So here's another math problem for you. Oxygen has 6 valence electrons. It has 6 and it needs 2 more to be complete. So how many valence electrons must each oxygen share? How much should each one share to be complete? How much should they both share so they can have the 8 that they want? I'll give you a hint. They both have 6, but they want 8. 8 minus 6 is 2. So each oxygen must give up 2 electrons. It will lose 2, but it will gain 4 that all of them are sharing now. So it has 4 on the outside here, but it has 4 in between these two. So now it has the 8 that it needs. And if we drew it in a Lewis dot structure, it would look like this. Here are the 4 that I had left over from not sharing, and then here are the 4 that the 2 oxygen shared in between them. Each little dash is 2 electrons, so 2, 4, 6, 8. Now the math works out, they both have the 8 that they want. That's a covalent bond when they share electrons. Okay? That is the last thing for your notes. We'll be practicing it more next week. Before you go, please write a summary. What is a covalent bond? And what did you learn today? Thank you so much, everyone. Have an amazing weekend.